All right, so now we're going to talk about our exponent rules. These are shortcuts. So before, when we were adding and subtracting our like terms, right, they had to have the same base, like the same variable with the same exponent, and we added or subtracted the big number in front. When we are multiplying, we can always multiply anything together. We can always squish stuff together. And then there's shortcuts to simplify, okay? So if we have the same base, and what we're talking about base, we're talking about things like if I had x squared times x to the fourth, okay? Multiplying, same base, right? And we're going to put these all together. So I'm going to write this out and then show you basically the shortcut, okay? If we have x squared, what that means is we have x times x. And then if we have x to the fourth, that means that we have 4 x's, okay? So if x squared means we have 2 of them, x to the fourth means we have 4 of them. So how many x's do I have all together? 1, 2, 3, 4, 5, 6. I got 6 x's all together. So what could I do between 2 and 4 to get to 6? Right, you can add them. We're going to add exponents. So we're going to add the exponents, and we have x to the 6. Not too bad, right? Okay. If we have something like this, call A, So sometimes if we don't see something, it's, our brains don't put it down all the time. But how many A's do we have here? Just right there. Exactly. We just have one, right? We have one A. And here we have 2 A's. And I don't know why I chose this, but I guess I want to make it long. Here we have 5 A's. 1, 2, 3, 4, 5. So how many A's do we have all together? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 A's all together. And I did that because I want you to notice that even though this doesn't have an exponent on it, it's considered A to the first. So there's a 1 there. It's never really usually written in there because anything to the first power is just what it is. It doesn't change it. So normally we wouldn't see it. But as we're adding and then later subtracting, we want to kind of remember that even though we didn't see that 1 there, it's still there. So our answer would be A to the 8th, okay? So we add our exponents, but when we're multiplying, if we had numbers in front, we would still be multiplying. So if we had 4x squared times 3x, this is where sometimes we get, we mix up our adding and multiplying. This is being multiplied, so we're still going to multiply 4 times 3. And we have x squared and an x here. And so 4 times 3 is 12. And then when we add our exponents, we have 2 x's here, 1 here. So all together, we have x to the third. Okay. Sometimes we might have more than just one variable. So we might have something that looks like this. Let's say we have x squared y times y to the fourth times xy squared. Okay. So Kind of all of a sudden we have more letters, but just think of it, x's go with x's, y's go with y's, okay? So if we wrote this out, we'd have x times y times 4y's times x times these two y's. Oops, off, sorry. So when you check, you say, well, I have these two x's here and that x here. So altogether, I have x to the third. And how many y's do we have now? 1, 2, 3, 4, 5, 6, 7. We have y to the seventh. So this is a long way to write it out, but this is how we get that answer, because some of you are really familiar with this, and you could look at this and say, okay, well, I got x squared and an x here, so I know I'm going to have x to the third, and all right, I wanted, and then here I have y to the first, and a y to the fourth, and a y squared, so you can do 1 plus 4, which is 5, and add this 2 and to get 7. That's the shortcut. And we've been doing this with variables, but it works the same for numbers. So if the number is the same, the base number is the same, it stays the same, okay? Meaning that if I have this, say 5 cubed times 5 to the fourth, I'm not going to multiply 5 times 5. I'm going to keep 5 because 5 is the same base. So I'm going to keep this as a 5. And then I'm going to add these exponents together. Okay. And your homework, there's one that looked like this. Oops, not like that. Okay, so it had 3 bases of 8. And we had this 8 and this 8 are both raised to the 17th power. Now, I don't want to write this out 17 times, and I don't want to write this out 17 times. So shortcut is we can add these two together, right? So 17 plus 17 is, I believe, 34. Well, we have this 8 with an N on it, and that's okay. But remember, we can't add numbers and letters and make it into one thing. So our base is still going to stay 8. Okay. We can add these two together, so we get 34. And I'm going to add plus whatever this is. Okay. Not a number. It's not a thing with only numbers left in it. It just happens to be 34 plus 10. There was another example, look kind of like this. Kind of weird, right? Like, what are you supposed to do with that? There's just a bunch of letters. But again, the bases are all the same, so you keep the same base. And then if these were numbers, right, we could add those together, just like this and that. We would get 3. Or 3 and 4, we get 7. But they're not. So just like we did here, we had to just let it sit as, this plus n. Then we're going to have this final answer be y to the a plus b plus c. And that's it. Why they have those questions, I don't know. But they do. Okay. So that's about it for that. Hopefully that made sense.